Good morning, everybody. Hopefully you can hear me. Welcome to our very first NTI Autodesk M&E webinar. So pleased you can join us, and lots of people from different countries all over the world. We've got a great lineup this morning for you. We're very fortunate that we've got three presenters from Autodesk, not just one, which is fantastic. So we've got insights on Maya, latest on USD, Bifrost, Arnold, etc. So really exciting morning for everyone today. Just before I kick off, I'll be very brief, but just to give you a quick update on NTI as a business. We joined the NTI group in September last year. You may well know us as BlueGFX. We're still the same people. Nothing's changed. We joined the NTI group to help build the M&E business. NTI is a global customer, a global partner, an Autodesk Platinum partner working in construction, design and manufacturing. And one of the reasons that we partner with them is to build the M&E business throughout the company at all the regional offices. So, and it's been a year already, and that year's gone very quickly, and lots going on, which is great to see. As a company, if you know us as BlueGFX, the same for NTI, we supply software, we supply hardware, we supply services, and we use the word expert support. Expert's a bold word, but in our view, it's really important that whether you're visual effects, animation, games, design, biz, or architecture, it's really important that we are able to understand your workflows and your pipelines so we can bring those skills and knowledge to our customer base. So really important to us as a business. Very quick summary now of the agenda before I pass over to John. We're lucky that we've got John, Roland and JP here today presenting. We've got a 1 hour slot, so there's quite a lot to pack in their 15-minute presentations, but John's going to cover Maya 25, modeling animation, new features. Roland's going to cover Bifrost and rigging, and JP is going to cover a quick overview of USD and Arnold. So without any further ado, I shall pass you over to John, just to say we will have a Q&A at the end. So if we can ask, please put your questions in the Q&A box. We'll cover as many as we can. We're going to do them after all three presentations, just because we're a bit tight on time. And any we can't respond to today, we'll respond to after the event. So I shall now pass you over to John.
Okay, hello everybody. Can you see my screen? Is that working? Great. Okay, so I'm John Caperton. I'm a technical specialist with Autodesk. I tend to look after the Maya side of things. I'm based out of London, the UK, but kind of focused on most of Northern Europe. So today I'm just going to be focusing a little bit, picking out a few highlights of the modeling and animation in Maya 2025. Let me skip the slide. There we go. Right, so before again, I just have to show you this. It's a safe harbor statement. So I'm sure you've seen these before, but if we make any forward-looking statements, we talk about products in the future, please don't make any purchasing decisions on those statements, just because it's not guaranteed that it will make it to the product. We think it will, we hope it will, we're sure it will, but it's not guaranteed. So yeah, just to cover that legal bit at the beginning. So just as a kind of a quick reminder, most of what we're talking today is, you can see here in this at the beginning of Maya. So when you start Maya, you have this little tab on the left-hand side, what's new. And if you want to refresh yourself at a later date, you can just refer to this tab and some of the topics we have been covering. And yeah. But excuse me, I'm just going to kick off with modeling and specifically some of the retopo improvements. So we've been doing incremental improvements to the retopo workflow Maya. We see this as a very important part of the asset or the build asset workflow. And some of the recent developments have been, and these came out just before Maya 25, but we have feature preservation and we have symmetry. So feature preservation is really a way of dictating edge flow, and you do that using the input geometry to drive the edge flow on the output geometry. This is very, very useful. And we've also introduced symmetry. So symmetry is a bit of a no-brainer, but when we introduced both these elements, they worked brilliantly apart, but actually they didn't play that well together. So we've done a little tinkering under the hood to make sure that they are playing well together, which they are now. So this is the example at the bottom left of them getting some really kind of nice results from that. The other part of the story is that is actually 30% faster as well. So That's got a lot to do with the underlying algorithm we call Reform, and that tech goes through several different of our products. So Max, Maya, but a few other products as well. So we have a separate team that is working just on that Reform algorithm. So this is getting faster and faster over time. So this is 30% faster than it was the previous version, and that is, in itself was 25% faster than the previous version to that. So if you used some of the retopology in an earlier version, check it out now and see how much it's evolved over a very short amount of time. But it will be getting faster and faster over time. So we're pretty happy with where we are with Retopo at the moment. So and it's pretty fast. It's pretty fast for small, for medium models, but it's not computationally free. It does take a little bit of time. So when you start getting to the amount of, say, 100,000 polys or 1,000,000 polys, it does take a while. So, and that very much happens in the forefront of Maya, not the background. It doesn't sit in the background. So it does freeze up your session of Maya whilst it's doing that computation. So we've been looking at ways that we could potentially offload that process. And one way of doing that is offloading it to the cloud. So we've done that. We've developed something that's called the Flow Graph Engine. It's out now. It's been out for a couple of months now. And this is an example of it here. So what we have a job submitter on the left-hand side. And all you do is click on the geometry that you want to be retopoed, put in the settings, and then just click submit. And that sends the job to the cloud. And you have this job monitor on the right-hand side here. It just shows you how far it's going to be completed. And then when it's complete, it gives you that green tick, and you just import that back into the scene. So very useful. It offloads that process and brings to bear some very strong compute power in the cloud based on the AWS platform. Now, what's really great about this is, excuse me, if you wanted to do, say, experiment with different settings. So if you wanted to do a wedge and send up, say, 5 different versions, all you have to do is click on the geometry you want to retopo and put different settings in the job and click submit, send them to the cloud, and they can all be processed simultaneously, which is fantastic. So you can just import those back in, and you can pick the one you want. So a very, very useful tool if you want to do some sort of wedging. Okay, now I'm just going to talk about some of the bevel improvements that we've got in Maya 25. These are great. They've been requested for some time. We've only just been able to really do this recently. So, but what it is, if you applied a bevel to an object previously, it would just bevel everything on that object. There's no way around it. So you had to go in there and explicitly select the edges you wanted to bevel, and then apply the bevel to that. Now that's fine. That's the way it's worked for 25 years, what we've done is added some very simple toggles. So we've got these toggles down here, and these very small toggles have a very large impact. Okay, so what you can do now, as of Maya 25, is apply a bevel to an object, and then just select hard edges, and it will only bevel the hard edges. This is fantastic. This is really kind of paving the way to more non-destructive workflow. So it's a little toggle, but it has a big impact. We also have it running through the Boolean stack as well. So on the right-hand side here, this is an example. You can see the bevels only happening with the interaction between the objects there. So again, something that's very powerful, a very nice thing. Okay, we're on to the Smart Extrude. So this is really cool. This is very exciting. We've been talking a while now about Smart Extrude. This is something that we've had in Max for a while, and people have seen it. I've seen it. I said, "Oh, that's so good. I want to see it in Maya." Well, now we have it in Maya. So if you don't know what Smart Extrude is, if you select faces and you pull them out with the Smart Extrude, it works exactly the same as a regular extrude. But if you push them in, it pushes in and cuts out into that geometry, and it does it in a very smart way. It cleans itself up as it goes, so it welds and bridges as it goes. So it does about 90%, 80 or 90% of the cleanup as it goes. You might have to go in there and have a look and just make sure that your edge flow is doing what it wants to, what you wanted it to do. But yeah, it's very, very, very nice. It's a very nice thing. And again, it's one of the things that we kind of wanted to point to and say, wouldn't this be great if we could just develop this once and share it across Max and Maya? And now we have. Now we can do that, and we can do that because of one thing. So this is a little part of the story, is that we have something, developed something called, we're calling GeoWorks, and it's based, well, it's under the hood. You don't see it. It's behind the scenes. It's transparent. But what it is, it's a new geometry format, but it's also a set of operations, and those operations allow you to modify or update that geometry. And what it can do is present meshes, point clouds, volumes, curves, and potentially quite a lot more as well. But the really important thing here is that it's inherently procedural and it's DCC agnostic. So the idea is we're going to start building future modeling workflows, and we build them in Geometry Works and we push them out into Max and Maya. So it exists in Max and Maya, even though you don't see it there, it exists there. So the reason why we have Smart Extrude in Maya now is largely down to some of this work that's been doing. So like I said, you won't know it's there, it's transparent, but hopefully you will be able to see it's going to be really paving the way for the next generation modern workflows. That's Max and that's Maya, but other places as well. Okay. So a good example of that work, and it's really coming to bear now, a lot of work has been done with Booleans. So in Maya 2023, a couple of versions back, we introduced the interactive Boolean stack, which is a huge step forward, because the first thing they teach you at modeling school is whatever you do, don't use Booleans, because it's going to give you messed up geometry and it's going to give you problems down the line. So here at Autodesk, we want to change that, because Booleans are an extremely powerful tool, but they're no good if you can't use them. So we've been on a mission to change that and developed the stack. So post 2023, they're much improved, they're brilliant, but still about 6% of that really complex Boolean operations would fail. So this is an example of it in the pink here. That's the example of it failing. It's pretty complicated Boolean, yes. But as part of that GeoWorks effort, we now have a unified Boolean engine between Max and Maya. So what we've done is taken the best of both worlds and created an Uber Boolean engine. So as of Maya 25.3, which just came out a couple of weeks ago, we now have bulletproof Booleans, no more fails at all. And what this does is pave the way to more and other exciting developments, which are coming soon. I want to talk about them, but I can't. Next time I will be able to talk about them, but yeah, rather exciting stuff coming. Right, I'm going to move on to animation here. We're continuing in animation-wise to work on the animator's quality of life. So we're kind of classing this next slide as, lots and lots and lots of small improvements that actually build up to something quite substantial. So we've done a whole bunch of work in the graph editor. So we've got hotkey changes, shortcuts. We've got cursor-centered zoom. This is the example on top right here. That was a little bit annoying before when you couldn't zoom in into your cursor. Key resizes on zooms and stuff like that. So lots and lots of little things. The bottom side, bottom left is, it turns out Max had a really good idea with color coded keys. So we've brought that into Maya as well. So if you've got translate, scale, rotate, and other keys, you can see that visually on the timeline. It's an option. You can turn it off if you don't like it, but a lot of people do like to see it in the timeline. And in the bottom right section here, we've got quick copy keys in the timeline. So what you can do is just select the keys or select a pose, all the keys in a pose, and quickly cut and paste it further down the line. Again, a small thing, but really speeding up kind of workflows. So an animator should be feeling this goodness of all these little things adding up to actually quite a lot. So in the last release of Maya, we introduced curve sculpting tools. And well, when they first released it, I thought, well, this looks quite nice, but I didn't think too much of it. But then we've had some really fantastic feedback, especially from people who've been using or trying to use mocap data. So mocap data is incredibly dense data. It's very hard to work with. and these brushes have become really important for people using this. So what we've done is actually added a new brush. So so we've got a key reduce brush here. So once you've got your animation curves in a place where you like them, you can just brush over the top of them and remove all the keys that you don't need anymore. So you can really reduce some of that dense data into something much more usable. So it's a nice little feature there. Okay. One of the bigger projects that happened was we completely and utterly overhauled the dope sheet. Okay, so why? Why work on the dope sheet? Because actually, it was not really being used in Maya that well for quite some time. It's what it is. It's an extremely powerful tool for retiming large sections of animation or characters or so on and so forth. But it's been really underutilized. So we've kind of looked into the reasons why this is, and it was old. It was clunky. It's not been worked on for a couple of years. So we've completely went to town on it, overhauled the whole thing. We've got cleaner, better interfaces. The interface is much more similar to the graph editor. We've got customizable color palettes. We've got ripple, edit, delete functions. We've got channel selection sets. These are super useful for setting up animations and stuff. There's so much there that I won't be able to go through it all today. We'll be here all day talking about it. But if you're an animator and you haven't used the dope sheet for a few years, which will be probably a few of you, I invite you to have a go at this and please give us your feedback. Tell us what you think about this new dope sheet editor. And then this brings me on to motion trails. So a whole bunch of work's been done on motion trails as well. So we've added a custom evaluator. Again, we've updated the code. We've made some real improvements, and as a result of that, we go from about 0.8 to a frame a second to 100 frames per second. So it's a real significant improvement. And as part of that, we went to town on the UI as well. So we've got a whole new bunch of draw styles. Things like acceleration can be displayed as different colors. You have more control of much of the visual elements. You've got offsets. Offset's something that's very useful as well. And so you've got lots of tangent editing controls, and it's all live. So it updates as you go along. And the other thing as well, you can lock a camera to a motion trail. So if you animate and you're using animated cameras and animated motion trails, it kind of didn't really work that well. So what you can do now is lock cameras to various motion trails, and just it's a much improved place to be. Again, if you're an animator and using motion trails, please give it a go in Maya 2025 and let us know what you think. So I've gone over my time already. That went very quickly. I've just wanted to say there's some things very exciting stuff that is coming soon. Hopefully next time we have a webinar, I will be able to talk about that in the not too distant future. But let me hand over to Roland Rare. Okay.
So yeah, I hope I'm sharing already. You see my screen.
Yes.
My name is Roland Reyer. I'm the technical specialist for Maya in Central Europe. So I'm based in Germany. And in this session, in this short session, hopefully, I would like to talk about some of the new stuff in Bifrost. So the question was, should I show you what Bifrost is altogether, which takes more than 15 minutes, or just mention what's new in the latest releases? Because the release cycle of Bifrost is so quick that it doesn't make sense to just talk about the latest release. But I collected a few releases, and I'm trying to update you on what's the things that are new in Bifrost. So I'm showing you the safe harbor statement because at the very end of this presentation, I'm going to talk about a release or talk about a version that's not yet released, just to make sure that you should not base any purchase decisions based on this presentation. So here's a quick chart about our release cycle. So you see that in the November last year, we released Bifrost 2.8, and in March already version 2.9, and in April already 2.10. So it's galloping, it goes really fast forward. Normally these releases do not break any compatibility, so you are safe to update them in the middle of the production, because there will not be any changes that break compatibility with older versions or with older scenes that you may have made. And there might be, and again, this is not an announcement, there might be another version in Q4 2024, which is for us extends until January. And we will have a look at that at the very end of the presentation. So in version 2.8, we had some new features. The most important ones were new materials. So we have an MPM gel. So MPM is the material point method, which is used to simulate not only clouds and smoke and fire and that stuff, but also, you know, things like gel and sand and snow and rubber, etc. So there are new methods in prefabricated graphs to let you simulate that kind of stuff. And there's also a new rendering method in the viewport. So this image that you see here is grabbed from the viewport. That's what you would see directly in the viewport when you do cloud simulation or any kind of simulation. That, you know, nano VTT viewport rendering is really amazing in showing you the final results of your simulation. Also new in 2.8 were new UI logic. So overall, a better user experience when using Bifrost 2.8. And then in version 2.9, there was an update again into the usabilities. So more of an educational graph. There is a bunch of examples bundled with Bifrost that you can open and have a look how that's done, how it's made. And now it's possible, here on the right side, you see in the image, it's possible to document the graph, you know, to have colorful backdrops and comments and formatted text that explain what is happening here and how you could use that for your own graphs, for example. You can dive into these graphs, so open up everything, everything's available, and everything lets you copy stuff and use it for yourself. One thing that started in version 2.9 is that we are going to have liquids in the graph. So currently, the liquid simulation of Bifrost, that's the old version of Bifrost, Bifrost 1.0, which is embedded in Maya. So it's an interactive way of setting up liquid simulations like oceans or, you know, pouring water from one container into another one. These liquid simulations are pretty fast, and you can save the results or save the simulation to disk to cache it, and then load that back into the graph of Bifrost 2 and mesh it, for example. And that is what we are talking here about. We have liquid meshing. That is something new that you see in the lower image here. That is a way to break down these simulations into polygons so you can render that. And what you see here in the upper image is the Bifrost Ocean simulation system. This simulation that you see there is really just a plane. It's a polygon plane with a lot of subdivisions to give you the details. And you feed that into BOSS, and BOSS simulates, or, you know, that's halfway between simulation and just an algorithm. It creates these ocean waves on top of that in a very short time. So this simulation type is really super fast. And that's the preferred way to show ocean motion and stuff like that. Also in 2.9, we had component tags now coming from Maya into Bifrost and can be used in Bifrost so that you can take parts of objects and act only on those. And also in 2.9, it was finally possible to use procedural modeling, like here in this module, where you hook up simple boxes of polygons and Bifrost creates complete buildings out of it. That is an example, you know, where I wrote some compounds. You can see them on my YouTube channel, and you can download them to build something like this one here, for example, a complete building with curtains and windows and things inside the apartments would be possible. 2.10 in Bifrost 2.10 in April, we got the new graph execution SDK, which means there's a that's a collection of functions that you can use in your own environment. So for example, or the end goal is basically that you would be able to use Bifrost in a game engine, for example, to execute graphs that you build in Maya, for instance, and then be able to execute them in the game engine to build some things interactively, which is a super cool way because Bifrost is very fast and would let you do snow, for example, on objects, or build cities, as you can see, as you have seen in the example before. There's a new node library in Bifrost, so again, user experience stuff. This node library lets you, slowly look through all the lists of nodes that are there and choose the one that you want. And there is continually updated list of example graphs that you will find in the Bifrost browser that are again, all documented and color coded, and so that you can see what's going on there, and use this stuff in your own graphs, or learn from them how things are done in Bifrost and use them in your own graphs. Here you see the page for the new rigging stuff in Bifrost. So there a bunch of rigging nodes has been developed, and this is something that is in the process of being completed and refined, the whole rigging, so that in Bifrost you can build your own rigging nodes. That's a super exciting thing. There are 61 new nodes of math and transforms and skeleton nodes and rigging solvers that you can use to build your own riggings. So rigging is something in Bifrost that is so exciting because you don't have to write any C++ code to make your own rigging solver, and you don't have to make any. So you see this here with the centipede example. That's really exciting that it, something like that can be built in Bifrost in visual programming. That might not be for anyone, but it's interesting that it's possible interactively from within Maya and Bifrost. And the things, or the kind of things that you can do, or the end goal is that you would be able to build things like this one here, shoulder setup, where you can use the wrist as well as the shoulder joint, where the clavicle is attached to the arm. And, this works on both ends of the IK system, which is normally a forbidden thing in Maya. So in Maya, normally you would have to, build huge networks of nodes to get anywhere close to this. Then in Bifrost 2.11, which came with the last update of Maya 2025.3, we have an updated version of the Bifrost data browser. So the data browser exists a little bit longer already. That is a way to, put such a tag here on one of the data connection lines in the graph, and it shows you what's in there. So in this case, it's an object. This blue color here shows me that it's an object, and it shows you what kind of data is in the object, and you can really dive deep in the whole thing and look at your data and check whether everything is as intended in this object. So you can really explore your data. Let's be clear with that. There's updates with Bifrost USD and Hydra. I'm pretty sure that JP is going to talk about USD, and he will certainly also mention Bifrost, because in Bifrost it is possible for you to build USD. So from within Bifrost, let's say we start from nothing, we can build a USD scene or a USD layer from within Bifrost and save it from there, which opens a whole world of possibilities, what you can do from Bifrost, and set up your basic USD scenes before you even touch them and lay your hands on them to build in something manually. And then something, when we talk about flow, it is possible now to do what we call wedging from within flow. So for example, when you set up a simulation like this one here, and you want to be able to simulate variations of that thing, you need to be able to say, hey, I want to have simulation settings A, B, and C. to be able to explore, you know, a little bit more gravity or more wind or more turbulence, etc. That's what we call wedging. So we split up the whole path of simulations into several versions of it. So you set this up, and then Bifrost sends a number of jobs into our Flow Graph engine, the online service that simulates it for you and gives you the ready-made simulation caches back so that you can load a cache and have a look at it and compare versions. So you don't have to do them one after another. You can do that within the graph and say, now let's start them all, and we get the results as soon as they are ready. That's a very important step to make your work faster so that you don't have to take breaks just to wait for a simulation. And then, you know, in the near future, I'm talking about Q4 2024 of this year, we look at more stuff. Textures are already in the make, so it's in the beta program right now, where you are able to not only load textures and use the data that is in there. You know, we have the texture and we have UV coordinates on the geometry, so I could take this texture and use these colors mostly as measurements and say, okay, I'm going to use the color to deform the texture, for example, or to drive simulation statuses or something like that. Not only that, you can also write textures. So you can use Bifrost to calculate your own textures and write them out again. That's a very exciting way of to use it. And when you load such a texture, you can sample it at any rate. So you can use lower sampling rates or very high sampling rates according to the thing that you want to do. And let's go back to the liquids in the graph. This is an example that I saw this morning on our internal message boards, a simulation that took like over an hour to simulate. But it's really amazing when you look at all the detail that's in there. So there are two simulations actually, or two data types in there. The one is the foam, the white stuff, or the bubbles underneath the water. And the other one is the water, the mesh itself. So these two mixed together give this realistic look at liquid simulations. We know that kind of stuff from Bifrost 1.0, which is integrated in Maya already. So that is very exciting to see that in the graph, because you can open these simulations and build your own simulation. If you have a different idea how liquids should be simulated, you can totally do that. You can build your own graph, and you can build your own presets for the whole thing. Not only presets, but your own processes, your own kind of programs to have this. Okay, so let's go back to this overview here. That was a quick look at Bifrost 2.8, 9, 10, and 11, and a quick outlook what is to expect in Q4 2024 with Bifrost 2.11 plus. Again, this is not an announcement that there will be a 2.12 anytime early, but you know, we are going forward in the direction of more releases and more features in Bifrost. That was my part. So now I'm going to hand it over to John-Paul Giancarlo, who is, I think, talking about USD and Arnold. Is that right?
That's correct, yeah.
So let me stop sharing. So we should see your presentations then. Yeah, it's coming.
All right. So hello, everybody. Yes, again, my name is John-Paul. I'm going to be talking a little bit or highlighting what's new, what we've been doing in regards of USD, Look DevX, Arnold, and a little bit of Hydra. So I also wanted to state that before we begin, please review our safe harbor statement. So, because we are making very forward-looking statements, and it's important that you understand this part. So, starting with USD, as most of you people know by now, USD, I'm pretty sure that you have heard of it at least. Universal Scene Description was developed and made famous by Disney, Pixar. Its purpose is to benefit production pipelines across VFX, animation, and gaming. But it is not just a file format, as you may know. It's a software platform or a framework for collaboratively constructing 3D scenes. We know production datasets are growing ever larger, and more people are trying to collaborate on those same datasets across different disciplines and even studios. And we know production pipelines need to be more flexible in supporting nonlinear workflows. So USD at its simplest really provides a file format that can represent geometry, caches, and time sample data. But more than that, USD is an extensible common language for 3D data, which is great, right? So it provides interchange between digital content creation, tools like geometry, shading, lighting, and physics, and very soon animation. So USD is not at all being developed in a silo at Autodesk. You might have seen this announcement around Alliance for OpenUSD. The Alliance is a non-profit organization dedicated to fostering the standardization, development, evolution, and growth of Universal Scene Description, OpenUSD, and basically to promote interoperability of 3D content. The Alliance, as you can see here, includes Pixar, Adobe, Apple, NVIDIA, and Autodesk. And together, we want to deliver standard specifications, so open source tooling and a community resources for the use of and growth of USD in media and entertainment and even beyond that. So here are a few of the current areas of effort of investment from media and entertainment standpoint around USD. Obviously, Maya, which I will touch on in more depth, 3ds Max, USD development is ongoing and ultimately opens greater interoperability between the Maya and other tools in this USD ecosystem. Arnold is likely one of the first to adopt USD into its development and continues to collaborate across other tools and DCCs to keep at the forefront of the development. Bifrost USD is an important one to discuss from the standpoint of Maya and working with USD in Maya. I will not touch upon Bifrost that much because I do have tons of videos that I'll be sharing with you in the chat. And then I'll be talking about LookDevX, which actually plays a role in USD material authoring and native material X authoring, which I'll briefly touch on. Hydra, on the other hand, which is development stemming from Pixar USD, which is also a touch on quickly. I will talk about it a little bit briefly. Presents what is next gen viewport and render solutions, and it's not just for Maya. So in addition to that, the Camari Software Foundation recently announced OpenPBR, well, not so recently, it's been there for a while, which is a new sub-project of Material X. Initially, it was created by Autodesk and Adobe with the guidance from the Material X Technical Steering Committee. So OpenPBR is a new open source shading model that will be the successor of Autodesk Standard Surface and Adobe Standard Materials. So OpenPBR really builds upon Material X by providing a description of how an artist will interface with the physical properties of the surface they're creating. The idea is to give artists a bit more specific interface to work within and the ability to transfer data back and forth between assets with a very little conversion needed. So, as you may know, it is an open source project initiative we're developing out in the open for studios and users alike to be able to modify and collaborate on development. The Maya USD GitHub repository exists, and I will share the link with you. Offers added resource for being able to glimpse into the development. So discussions and issues and access to code for everything, pipeline requirements, everything's being discussed there. Maya USD to date has seen more than 20 releases by now. So supporting USD, starting from first release in Maya 2022 to the Maya 2025. And the latest release, unfortunately, no longer have back support for 2019 and 2020, but previous release too, in case you are still stuck in 2029 or 2020. The development efforts have been substantial from the initial visualization of USD data to the addition of features and workflows that allows for studios to quickly adopt USD in their pipelines. This is the whole point of having this in the open. So Maya USD is a critical element in our USD ecosystem, as you may know. So it will continue to grow and mature based on continued customer feedback or stories that we hear in the forums. When Maya first released, or Maya USD first released, we have features like, it was a USD shot-based animation system, so it was very robust for export and import. We have a layer manager, we introduce layout and assembly workflows. USD support in the outliner, USD stage directly in viewports. We have pre-access in viewport, pre-match with editor, USD camera, all this stuff. And the whole idea was that you could select any USD prim and transform them natively or convert them to a Maya object for input into the formats, for example. So going back and forth from Maya to USD. So in Maya 2024, we improved shot-based animation, so integrated USD with these plate layers and added relative path support, what's really, really important. By Maya 2025, we had improvements to edit routing, so you can more clearly see and choose where USD edits are stored, copying and pasting USD, for example, prims, even across DCCs, and a set of safe USD preferences that make the user experience better and more efficient. Relative path in all aspects of USD, I have to mention, and it was cementing interoperability workflow by enabling easy access sharing workflows using this relative path on demand, pretty much. So again, I will be showing a little bit of this edit routing and explain a little bit what edit routing is to you if you're not sure what this is. Show you a little bit of the USD preferences. Again, all the stuff that we've been doing. So I'm just gonna now show you a little bit of a image where you can check whenever you or referencing an object or importing a USD file where you can check that. Here a little video. I know might not be playing correctly, unfortunately, but it's as simple as just clicking or checking on the box right there, and now you have set the path relative. We also have now in the layer the ability to lock specific layers. So you can select the layer and just, as you see, you have little lock. If you click that in there, you're good to go. So no edits are going to happen on that specific layer. So this in the UFV front, universal front end, you can now also select an object in the viewport and get access to edits by right-clicking on the selected object, as you can see there. So you have different things so you can, or edits so you can perform by just right-clicking. We also added the ability to bulk edit, so which means that you can now select multiple objects and make edits to all of them at once, which is super, super important, I have to say. And the ability to set the default prim from a selection. So whenever you're creating a USD from a Maya file or doing it in the actual Maya file, instead of referencing, you can set whatever the default prim is going to be. So you can see here, you just set the default prim and you're good to go. So we also improved a lot of the referencing side of things, as you can see in this image here, within the red circle, where you can set the composition out with this reference load, what kind of list edited as, is this a append or that kind of thing. You can see here it's very simple. Just whenever you reference an object, you have that composition out there, either payload that or prepend or append. Make path relative again, and then you see that's real time, and it didn't speed up anything, so it loads pretty quickly. We also added hotbox and marking menus, which is, you know, like super important, I guess, if you want to work a little bit faster and I have to go navigate the entire viewport in order to do simple things. Now, what about edit routing? And let me explain this. Currently, when typically modifying USD data, these modifications are reading to the current edit target layer. So the current layer is selected in the layer editor window in Maya normally. So edit routing is basically a mechanism to select which USD layer will receive edits. So when a routable edit is about to happen, the Maya USD plugin can temporarily change the target layer so the modifications are reading to a specific layer instead of the current target layer. So this mechanism allows advanced users to also write code or scripts or plugins to handle the routing, which is fairly useful. And the script receives information about which USD prim is about to be changed and the name of the operation that is about to modify that prim. In that case, also, if attribute changes, the name of the attribute is also provided. So given this information, the script, you can choose a specific layer among the available layers. So edit routing is divided in two categories, commands and attributes, basically. So if you want to know more, let me know. I will send some documentations in regards of this. And when it comes to preferences, now you have access to specific USD preferences there. So you can set default, say, if you want to save as a binary or ASCII, and a bunch of other things there when you're building the or publishing. And in the future, we are also introducing USD animation. So we're actively working on USD animation support in Maya, and we're decoupling artist tools from data models. So let's call it UFE, or Universal Front End for Animation. And first, we want to allow artists to edit USD curves natively with our graph editor, dope sheet, etc. And next, we want to build a more powerful artist workflow built on top of USD anim. So which is how we're calling it now, might change. Outside of Maya now, we also added support for Motion Builder in 2025, so you can load USD, mix USD stages in Motion Builder. You have Python state creation, all that stuff, USD plugin source available also via DSP. Now going to Look DevX. Oh, sorry, I went too fast. So this is another exciting and notable open source and open standard initiative, really. So it was launched by ILM, so Material X. The goal here is to create materials once and use them everywhere. This would allow for look development and material workflows to ideally be used interchangeably between renderers and different DCC tools. And Material X is now integrated into Maya, Max, and Arnold with Look DevX. So Look DevX is quite an exciting one. Look DevX is a brand new material authoring tool, which is intended for multiple data models, starting with USD. So that's the very first one. The development mission is to enable standardized portable materials workflows that will support our vision, where materials can travel freely and accurately through any current and foreseeable customer pipelines. And additionally, make an artist-friendly tool set with graph management, troubleshooting, tool sets, and intuitive creation and publishing workflows. So this is actually the first release of Look DevX, and the one that I'm showing here, and it offers the ability to create USD shade graphs and author custom materials in Maya. It currently features support for USD Preview Surface, Material X, and Arnold shaders, and opens the door for abilities to work across multiple content creation tools directly with USD data to assign. Adapt and create. You can definitely create materials all within the Look DevX graph editor. So my user can open the Look DevX graph editor and quickly see resemblance to the Bifrost node graph. So because it's built on a same VNN or network engine, right? So it's similar in design. Look DevX contains node-based connections for building material networks with editable parameters and with the ability to work with compounds to simplify graphs down to only what is required. It's extremely insightful tutorials like Arvid Snyder you see here. He works on creating and working with Look DevX to generate amazing results with insightful tips and tricks. So I would encourage you to go ahead and watch his tutorials. So these are pretty useful, pretty good. And there's a bunch of new Look DevX tutorials on our YouTube channel. So don't miss out. Now, looking forward, the team's also working on AI-enabled workflows like AI text generator, material generator, HDRI, and we also hearing suggestions. So in this first one you see here, you can generate a texture from a prompt. It's as simple as that. Set styles and define resolution. But also, after the fact, you can generate or extract bump, normal, and displacement maps from the textures that you just generated. On the other hand, we also have worked in the past where, an integration of NVIDIA Picasso into Look DevX, and that's something we did partnering with NVIDIA a while ago. So it is a possibility to integrate different algorithms or make your own and make it work inside of Look DevX. So now going into Hydra for Maya, I just want to talk a little bit about the current progress. So Hydra is an open source framework as part of the Pixar USD distribution. So it's intended really to decouple applications and renders with this design of scene delegate and render delegate APIs that basically would allow for many different applications to ingest scene data and multiple renders to output. as you can see in this image here. So Autodesk is actually working closely with the open source community to extend Hydra to be able to add functionality that may not be currently available there. And in this example, we look at the possibility of many different Autodesk products fed into Hydra and proposed render delegates like Storm, Aurora, which is Autodesk real-time path tracer, which has actually just recently been announced. And that was actually announced a couple of years back. And Arnold is an example production render. But you can also get like Houdini, Unreal Engine, and I will show you a little bit of that. So our goal is make sure our applications are a great host for native Hydra viewport. So we can build on it, our partners can build on it. We have a path to leverage investment going into other renders as well. So the maintenance is reduced and it's transparent for all users. So we have a focus on UC-driven workflows initially, and I think going forward into the future. So we look back at M2H and our prototypes and thought of what we could do make Hydra, the viewport for Maya. We are reworking our APIs to make the data translation to Hydra efficient and to allow third parties direct access to Hydra without the need to go through Maya's data model. We call that scene index. The feature set is limited currently, so things like modeling workflow, selection, native Maya materials are missing features and functionality at the moment, but it is, we have a team working on this every day. A technology preview of Hydra for Maya is available as well with Maya 2024, and it's part of the Maya USD, and it is also open source, that's important to say. So it is why open source, because we want to work in the open and drive the technology, so embrace the community effort and enable our customers to integrate Hydra for Maya in their pipelines, basically give third parties an open standard to plug in new renders technology. And you can see here, there's a little video of Hydra actually working inside of Maya. So with Hydra and Maya, we're not the first to begin development. Really, there was already a Hydra-based viewport in Maya USD called M2H. Maybe you are familiar with this. It was originally developed by Luma Pictures, and while it showcased the potential, it was limited by the APIs Maya has exposed at the time. So the data handling, the translation was not efficient, and there were limitations with what could be done with native Maya data. We also explored different prototypes, like running Unreal Engine inside of Maya, as you can see here in the video, and it runs next to Viewport 2.0, and it works, but it's more of a rendering view and not a viewport for interaction, really, which is still good. Like if you have Viewport 2.0, and besides that, you can have a really pretty neat representation of your final render. Again, this is this open source repository. The code base was moved to its own repository, which you have there, the link, if you want to grab that. What does change? All Hydra development will happen in the Maya Hydra repo now. So again, we're working in the open. New CLA needs to be signed if you want to contribute, which means if you want to contribute, you need to sign some stuff, some documents. What doesn't change is we're releasing this with USD for Maya. So now going into some of the Arnold highlights, and there's tons and tons of new features added, and I cannot cover all of them in 15 minutes, so that's why these are just the highlights, the things that I feel are important. So we added inside of Arnold the overlay imager, which decorate or tag your render by printing text over the render images. Let me show a little bit here how that works. So you have a render image, and if you set that overlay, you can see, for example, different things. So you can input like frame or time or size or what was rendered with, camera information, all this stuff. The Arnold team also added USDZ support, which is quite important, and we identify a lot of the team fixed the discrepancies in rendering between the Hydra render delegate and the USD procedural. So they've been working very closely in order to make a USD ecosystem that is very robust. And we'll see that in the future. So Material X and USD as well. So we improve support for Material X and USD. So it is production proven. It is still early to recommend as a technical solution, but it is production proven. You can start using it today. And there's a growing list of DCCs. So Maya 2024, LibDevX, we have Houdini Solaris, and etc. So it will continue to grow. Now, in terms of shaders, the Open PBR surface over shaders, as one of the new releases, it aims to be capable of accurately modeling the vast majority of CG materials using practical visual effects and feature animation productions. The model has been developed as a synthesis of the Autodesk standard surface and the Adobe standard material models. So LibDevX and Material X, we have native Material X and LibDevX in Maya 2025. We also added displacement, and we're mixing Arnold and Material X nodes, which are pretty important now. So you have the ability to mix those, like curvature nodes that did not exist before on Material X. There's a big focus on NPR rendering, so there's a lot of tone improvements, like now have light group AUVs, better contour lines. We also have a C++ shader revival. Custom writing shaders, so BSDFs to achieve very specific looks. You know, they're using the API to inject curves, for example, pointing the scene at render time, delivering shading API improvements, and bulking up post-processing capabilities in future versions. So Imager API, so you can develop your own imagers and you make your own imagers. So here's some of the improvements you can see on the toon shader. Some things that were missing in the past, like not completing the contour. You can see in 7.2.4, you can see that's fixed. So a lot of little things there. And you can see here a little example of what Micros did on the Teenage Mutant Ninja Turtle, where they actually leverage all these new abilities inside of Arnold or features in order to create this really amazing thing that is not running. So we also have the distance shader, which is a shader that's driven by distance, or drive shader called by distance. It's similar to the V-Ray distance shader. It's no displacement support for it now, but we have for further improvements on this. So distance and direction output, consistent in reflections and refractions. So there are things that are missing, but you'll see it's getting fixed slowly but surely, as you can see on these images from the left to the right. There's a little video here of how that works. I'm not gonna play it completely because I do not have optimized audio and sound, video and sound. Well, I might be broken up, but you have an idea of what you can achieve with it? All right, sorry that I cut that. It's just I'm pretty sure it's not playing correctly. So in terms of performance now, we have worked on the global light sampling. So there's a new, more efficient sampling technique for lights. Single sample setting for lights. There's large speed ups in scene with overlapping light contributions. And releasing 7.2 improve in every version. So GPU support, volume support, production feedback, and fixes. So a lot of people's feedback. So we're fixing those, and the team is really concentrated on fixing any bug in regards of how this works. In general. So global light sampling on GPU, you can see there's a huge speed ups. Like in this city with 100,000 lights, it's a 48x speed up. There's this classical interior, for example. There's also 2x automotive studio with 9 lights, the 2.6x. And yeah, this is also an important one. It's the fastest startup and IPR. So 20% fastest startup time improvements on large scenes. We have fast modifications for camera, shader lights for complex scenes with multiple levels of USD, 1.6x faster points in USD. And I just wanted to show a little bit of a demo on, this is not sped up. This is a recording I did. I have a Quadro RTX 4090 on my laptop. And you can see it immediately starts populating all the data that it needs in order to start rendering the scene. The scene that I'm rendering over there, you see on the right, is it's got some complex objects, but it's not really that complex, but still, normally it would have taken about a minute or so just to start rendering. Well, now it starts rendering a lot faster. We also improved thick curves, so it's much better looking, and on average, it's also 10% faster, which is quite cool. We reduced noise from mesh lights in volumes. That's Arnold 7.2.1. You can see 7.2.2 now, so much cleaner. So you can see here. So in terms of GPU, Intel added support for Intel, NVIDIA, and AMD GPUs in the Intel Denoiser version 2. So which is quite good. You can start using this denoiser with any other graphics card anyways. There's a GPU render overhaul, so it's a large part of the GPU render was rewritten using NVIDIA OptiX 8. So which means, again, translate to much faster rendering time, startup time, sorry, better scaling on multiple GPUs. It's faster to render and also uses less GPU memory. And one thing that is important is that now we've achieved GPU parity. So script-to-mat, motion vectors, toons, everything working inside of the GPU. So there's a lot of, hope around in the community. So people really testing Arnold daily just have amazing stories to tell, and they have great comments in regards of how Arnold is working today. And I think that's it for me. I really wish I could have more time to share a lot more of the stuff that I have, but I don't. So I guess I just pass the word to the next.
Thanks, JP.
You're welcome.
If you unshare, then I can just share the last slide.
Yeah, sorry, I lost my. There you go. There, appreciate it.
Okay, thanks very much, JP. Great presentation, and also Roland and John. It's very hard. It's like speed dating. It's very hard to fit in all the information you want to get across in 15, 20 minutes, but that was really, really good presentation. So thank you. On the Q&A front, we've been answering questions as we've gone along. So we've run over time slightly, but if there are any other questions, please put them in the chat box before these guys disappear. I think, Roland, you've just answered some recently. John, you've answered some. I think, JP, you were answering some before you were presenting. So I don't think there's any more questions at the moment. And on someone saying thank you, that's good. Hopefully everyone's really enjoyed the sessions. I found them really useful myself, and really good to have 3 of these top specialists at Autodesk telling us about the new technology that's coming from media and entertainment. So can everyone see my final slide? Hopefully they can.
No.
Just
no,
to
we
say,
can't. No, we can't, Matt.
Okay.
We can't see your slide.
Yeah, whilst you're looking at that, I'm just going to say we're only really scratching the surface of what was new, really. So we're very happy to come back and talk to any of you guys at a separate point. So one of the things was machine learning. I would love to talk about that. We've got that in mind now. So
that's great. It's a lot to pack in 3 15-minute sessions, but really good. So look, if there's no more, I can't see any more questions.
So we just had one in Steph's just asked a question just about whether the ability to load textures and potentially apply them on procedural models in Bifrost using selections was the question.
Yeah, it's a good question. What that means using selections. You will be able to load textures, create textures in Bifrost, or load them from files. You will be able to analyze the data, read the X and Y position of the pixels and the values of the pixels, and then apply them as you wish. So if there are UV coordinates on the surface, on the geometry, you have access to these UV coordinates. So you can use that to say, hey, this pixel belongs there on the geometry. That is totally possible. Apart from that, it's an open system. You define what you want to do with it, and you define the effect that you want to create with it.
Cool. Thank you, Roland.
Thanks, Roland. Any more questions? I can't see any more. I think they're all answered. Can everyone see my slide now or not?
No,
Nope.
Now?
no.
Nope.
Okay. No idea what's going on there. Okay, well, just to say to everyone, thank you very much to our presenters, three Autodesk guys, really insightful presentations, really appreciate that. Thank you to our guests and thank you everyone for staying on beyond the hour. I'm sure you're busy people. If you have any other queries, we'll be following up with a survey, feedback survey on the presentation. So it'd be lovely to get your feedback, please. And also any other outstanding queries, please, you can send those to webinars@bluegfx.com. I'm not sure why you can't see my slide, but you can't, unfortunately. And we're very happy to talk with any of you about your workflows, your challenges, your pipelines, or any other Autodesk related products. So from all of us here, thank you very much. Have a great day, everyone, and look forward to seeing you at the next webinar.
Thank you,
Thank you.
everybody.
Thanks,
Bye-bye.
everyone. Cheers.
Have a great
Bye.
Happy Halloween.